Hey Ed, this is Shravan. This is my demo for the audio engine. I really hope this video is fine because the earlier one had some stupid watermark on it, so it's just crazy. Anyway, so like before going into it, I'll just show you like a class diagram so you know that we have the overall structure going. So you can see, here we go, right? So you have a sound points to the A sound and they go back and forth. The A sound has a user callback hanging off of it. A sound points to a playlist, points to a voice. The voice points to the buffer. The buffer actually, voice points to a wave. The wave owns the X audio to buffer and format. And the voice also points to the to our voice callback. The voice callback further points back to the A sound. Um, so that once it ends, we can access the A sound and stop it. On the game side, just to show that everything is going off of commands. So you have the A command that has its sound, and then these are all the commands that sort of go across the queue. So that's it. I'm gonna start playing off the first demo now, and right, here we go. Okay, we are still going to instance one sound, so there's just one of them left. Alright, there you go. So you saw that, hopefully you heard all the panning going, the volume being ramped up and ramped down, all that happened in different threads, and then the song in, song me times as requested, they were inside over here. So next up is Seinfeld, and again, before I play it, I'll just show you what I did. So I subclassed a specific, a special Seinfeld playlist. I subclassed a callback. And what I do here is pretty similar to what I did in PA4. I just have a linked list of Seinfeld data, which points to a wave, just so we could print the wave name. And what happens is that the callback essentially cycles through this list of buffers, and as one buffer is done, sorry, as one buffer is done, it goes ahead and submits the next one to the voice. Otherwise, it's just gonna go and end. Uh, so yeah, I'm just gonna play that too. Here we go. All right, so that was Seinfeld. Um, so the next demo is priorities, and this was the hardest one for me. Um, but essentially, what I came up with was that once after, of course, I have the priority table, I have it on the sound, and so the way that I do it is that whenever I add an element such that my table gets full, I immediately sort it, and I sort it using bubble sort. So yeah, don't judge me. But the idea being that whenever a next element comes in, if there's ever any sort of contention, we immediately, we can go and compare it to the last one, because the last one would have either the highest priority or similar priority, but it would have been playing the longest. So the idea being that if there's a free slot, just go ahead and take it. Otherwise, check just the last one, and we just need to compare the priority, because even if the priority is equal, the last one would have had less time, so the last one would have been playing longer. So that's the idea behind it. um, Everything, of course, is being done with handles, so you've got handles both on the sound and on its the priority table right here. And so yeah, I'm going to play it now, and there's going to be a party down here. Here we go. Okay, so you can see that started off with the first three sounds. Um, After that, you added the fourth, added the fifth, no problem. Once you add the sixth one, the table immediately gets sorted. Now with contention, you can see that we add a new 150, so this one gets knocked off, and this one is the new one. After that, you add one with 75, so now the 150 is gone. The new 75 comes in here. The table is sorted again. Similarly, you add another 75, so the 100 is knocked off. The new 75 comes in here. The table is sorted. Similarly, another 75 will come in. So now this one's been playing the longest. It's going to get knocked off, and the new one comes in here. The table is sorted. Finally, you try to add a 150 priority. So there's no space for that on the table, so it just gets rejected. So you have that being printed out over here, and then in the end, of course, we stop all the sounds, and the table is empty. So the next thing is game user callbacks, and I'm actually going to play this first and then sort of go behind what I did, because I think I already showed you the diagram. So here we go, user callbacks. Alright, so you saw that we had four sounds, and we had four callbacks attached to them, and the callbacks came back, they printed the data. So for this one, I'll actually take you through the demo where I use it, and the oh man, 1 second. So the idea basically is that here's my user callback. So our sound managers and sounds are hooked up, so we can optionally pass callbacks inside them. That's what I do here. The callback itself is pretty simple. It associates with the sound, it has a wave name, and the only thing it does is prints what we saw over here. The idea is that the XORIO2 voice callback goes back and triggers an A sound end command. And there's a lot of going back and forth between the sound and the A sound that's happening. 1 second. So here we go. So the idea being that we have this A command queue that just essentially is used by this XORIO2 callback, and we do is this guy gets the sound from the A sound, then actually sends the sound end command using that sound. This is going to go across the queue, get the A sound, and finally end it. So the idea being that finally when we get to the A sound end, if we have the callback hanging off of the A sound, so if it exists, that's where you set it, and that's where you fire it off, and we get this. And then of course, the end sound is also responsible for removing the sound from the priority table, and all the other stuff. So that was callbacks. The last thing now is async loading. And I'll just go through the diagram because this was the fun one. Good God, this is slow. All right. So here's what it is. I have a game loading callback that I create with, a blank sound pointer. And the idea is that this guy, when it executes, is going to actually create the sound and play it. Uh, so upon construction, the game loading callback creates an async load command. This goes across the queue onto the audio side. When it fires, it creates an audio file callback and associates this game loading callback with the audio file callback. Once the audio file callback is constructed, it creates a file load command. This guy goes across the queue to the file thread, and when he executes, it populates the wave and format that's associated with this, and then it calls the audio file callback. The audio file callback, when it fires, is gonna associate a wave with these two, and then call its corresponding game callback. Now, when the game callback fires, we know for a fact that the wave has been loaded, so it'll add the sound and play it. So if I just, show you like the chain of events over here, we're in the file command here. So it's going to call its audio callback. It's going to load the data. It's going to call the audio callback. The audio callback is going to go across and create a wave, and then it's going to call the game callback. And this is actually now going to create the sound and play it. So with that said, here we go. This is async loading. So, all right, that was Beethoven, that was async loading. Um, and just a couple of things right off the bat. Apart from this, I've already shown you. So everything has handles. So we are handle protected. So I have handles on my sound manager, on my priority table, on my voice, and on my voice manager. I decided not to go with handles on the A sound because I thought if we have the sound and if we have the sound and the voice handle protected, we should be okay. Um, One more thing that I wanted to just show is that um, so I have all my audio is actually being initiated by commands going from the game side. So before each demo, I have this function on my sound manager called load demo audio, which essentially creates a new load command with the type of demo that we need to send across. This is going to go across to the audio side, and then based on which demo it is, it goes ahead and it loads. So game loading is done on the game side. Um, and the other thing I wanted to show was that the next thing I wanted to show was that all my demos are essentially commands that go across the timer. So yes, the timer is working. And I think that's about it. And I have this line here, stop active sounds, to sort of clean up between demos. Other than that, I'm definitely leaking, but I hope that's okay. It's still sort of stable between all the demos. So that's it. Thank you so much for watching. Have an awesome summer. I'm really sorry about the video delay. For the life of me, couldn't figure out where that watermark came from. Anyway, have a blast, and I'll see you during Engine. Thank you.